Hey guys, how are you doing? Today in this video, we are going to talk about satellite internet. Imagine a child in the remotest village of the Himalayas opening a tablet and instantly connecting to the same internet speed as a student in the New York. No cables, no towers, just satellite floating thousands of kilometers above us, weaving invisible bridges of connectivity. This is not science fiction, it is the dawn of satellite internet. From Starlink to India's own ventures, the sky is becoming the new highway of information. But with promises of bridging the digital divide come questions of regulation, security, and affordability. Today, let's unravel the story of how satellites are set to redefine India's digital future. We are going to start with this video, and we should first talk about internet connectivity has become absolute necessity among all of us, not only among civilian but even military domain. So why we need, first of all, let's discuss why we need satellite internet. There are limitations of ground based networks, and let's discuss quickly about them. So ground based, we have ground based network, and these networks have some limitations. तो हम लोग कौन सा इंटरनेट यूज करते हैं? जैसे मैं फाइबर ऑप्टिक्स यूज कर रहा हूं, एंड वी कॉल दिस OFC cables. They are fiber optics, optical fiber cables. Basically, the full name is optical fiber cables, and it is based on the simple principle of it is called total internal TIR, total internal reflection. तो इसमें होता क्या है? This is a denser medium and it is optically rarer medium, and when light goes from denser medium to rarer medium, it gets partly reflected or partly refracted, but for specific condition, it gets completely transmitted in the same media or reflected back in the same media. This is called TIR, and it gives you utmost speed, very good speed, I mean reasonable good speed, and this is what we are using, right? So ground based networks, they use cables, towers, we have broadbands, है ना. उसके अलावा हमारे पास क्या होते हैं? ब्रॉडबैंड्स, OFC cables. These ground based networks have, they have towers and cables. Essentially, they are based on cables and towers. But what are the limitations? If you were to talk about limitations, so there are many limitations. For example, physical infrastructure is, physical infrastructure is very costly. Physical infrastructure, you have to create physical infrastructure everywhere, है ना. Suppose, as if you are living in a metropolitan city like Delhi, Mumbai, or Bangalore, then these physical infrastructure, you will have a cost, benefit analysis, and you will have benefits. But suppose आप कहाँ पर रह रहे हो? किसी desert area में रह रहे हो. For okay, suppose if you are living in a desert area, है ना, तो अगर आप कहाँ पर रह रहे हो? Maybe in desert area, है ना. सपोज आप ओशियन के बीच में हो, इन द मिड ओशियन, है ना, जैसे कि लोग जॉब करते हैं मर्चेंट नेवी फॉर एग्जांपल. अगर आप किसी हिली टेरेन में हो, है ना, जहां की पॉपुलेशन बहुत कम है, फॉर दैट मैटर इन ले लद्दाख, लेट से चंगपा कम्युनिटी, है ना, अगर चंगपा कम्युनिटी को आप इंटरनेट देना चाहते हो, और फॉर दैट मैटर एनी अदर कम्युनिटी, तो आपको बहुत ज्यादा फिजिकल इंफ्रास्ट्रक्चर पर क्या करना पड़ेगा? इन्वेस्ट करना पड़ेगा, है ना. तो ये क्या है? एट सम प्लेसेस, रिमोट प्लेसेस, एंड इट इज इकोनॉमिकली अनवायबल, है ना. तो इट इज इकोनॉमिकली अनवायबल ऑप्शन, अनवायबल फॉर स्पार्सली पॉपुलेटेड एरिया, फॉर स्पार्सली पॉपुलेटेड एरिया, है ना. एक ये सबसे बड़ा लिमिटेशन है. अगर वहां पर लोगों की क्या है, और हर इंसान को, एवरी पर्सन हैज राइट टू हैव दिस काइंड ऑफ सर्विस, है ना, इंटरनेट सर्विस, राइट टू कनेक्टिविटी, मे बी यू कैन से लाइक दैट, है. अच्छा, उसके अलावा फॉर एग्जांपल इफ यू वांट टू टॉक अबाउट डिजास्टर्स, अचानक से कोई डिजास्टर्स आ जाए तो दोबारा से सेम फिजिकल इंफ्रास्ट्रक्चर को क्रिएट करने में बहुत टाइम लगेगा. फॉर एग्जांपल क्लाउड बर्स्ट इवेंट्स, राइट, वी हैव सीन GLOF इवेंट्स आल्सो, वी हैव मेड वीडियो ऑन GLOF, राइट. सो ग्लेशियल लेक आउटबर्स्ट, फ्लड्स. फॉर एग्जांपल वी हैव अर्थक्वेक सिचुएशंस, है ना, वोल्केनो सिचुएशन, पर अर्थक्वेक बहुत कॉमन है. फ्लडिंग सिचुएशन, फ्लड, है ना. उसके अलावा जैसे हमारे पास लैंडस्लाइड हो जाती है, तो लैंडस्लाइड भी क्या करती है? जो फिजिकल इंफ्रास्ट्रक्चर को उसको क्या कर देती है? खराब कर देती है ना. तो डिजास्टर्स प्रोन एरिया में ये बहुत दिक्कत है. अच्छा, डिमांड फॉर ऑन द गो कनेक्टिविटी, है ना, डिमांड फॉर ऑन द गो कनेक्टिविटी. अगर आपको एक जगह से ऑन द गो कनेक्टिविटी दूसरी जगह जाना है, तो आपको एहसास होगा कि अगर इंटरनेट नहीं होगा तो आपका ऑफिस का काम या फॉर दैट मैटर योर एसेंशियल वर्क इट इज स्टक, है ना, क्योंकि आपको दैट काइंड ऑफ कनेक्टिविटी इज नॉट अवेलेबल एवरीवेयर. दीज आर right, these are the basic challenges, and here is a powerful solution, powerful solution, powerful solution to these challenges, and this powerful solution is basically what? Satellite internet. This is called satellite internet. So satellite internet is a revolution, and this satellite internet has two primarily. This satellite internet is capital intensive and it has two component. One is space component and others are space component, and others are basically a ground based component, है ना, ground based component. These space component essentially have satellites, सबसे पहले तो क्या है? सैटेलाइट है. इट इज कैपिटल इंटेंसिव satellite, and even constellation of satellite if it is in low orbit, which we are going to talk. Constellations, thousands of satellites and their payloads also, which is why it is capital intensive, है ना. ये कैसा है? Capital intensive segment है. And ground based, they have for that matter you have antenna, you have receivers, so on and so forth. This is what satellite internet is. But this is what functions regardless of the terrain or presence of any terrestrial infrastructure, right? It can function at global level, right? It can be deployed rapidly to manage sudden demand surge, and it also provides connectivity within the moving platform, for example airplane or remote sites such as offshore oil rigs. So satellite internet is not merely a backup system, it is a transformative technology with the potential to reshape the digital economy, right? Okay, so let's talk about now this satellite, these satellite internets, the satellites for these satellite internets are deployed in three main orbits. Geostationary, one is geostationary earth orbits, the others are medium earth orbit and the low earth orbit. And if you know the basic physics, how do we define this? So suppose we have this planet, I can quickly make you basic calculation, and this is a planet, our earth planet, है ना. तो एग्जांपल अपने अर्थ प्लैनेट का लेते हैं, एंड सैटेलाइट इज अ बॉडी व्हिच इज रिवॉल्विंग अराउंड दिस प्लैनेट. तो ये सैटेलाइट है और ये सैटेलाइट क्या कर रही है? इसमें क्या कर रही है? रिवॉल्व कर रही है ना. दिस इज रिवॉल्विंग अराउंड. ओके, तो इसको ऐसे थोड़ा सा घुमा दो, एंड दिस इज द सैटेलाइट व्हिच इज ऑर्बिटिंग इन दिस कर्व, एंड लेट्स से द वेलोसिटी ऑफ दिस सैटेलाइट इज से v0, ऑर्बिटल वेलोसिटी. दिस इज द मास ऑफ द अर्थ, radius of the earth, this is the height of the satellite from the surface of the earth. And typically if you know the values, me is 6 or otherwise 5.9 into 10 raised to power 24 kilograms, and radius of the earth is 6400 kilometers. The value of g which I am going to use 6.67 into 10 raised to power minus 11 Newton meter square over kilogram square, 9th class science. So to move around this orbit, it needs centripetal force, and this centripetal force is mv naught square over r, is typically, and not typically actually, you get it from the gravitational force gmm over, or otherwise gme over r square. Once you cancel out this m and you cancel out one r, you are left with v naught square, and from this you get v naught is under root gm over r. This distance r is, quickly I am telling you this basic mathematics if you want to understand. This r is basically re plus h. Okay, so if I want to calculate the time period, the expression for time period will be t equals to 2 pi r under divided by v naught. So 2 pi this r under root gme, and this under root goes upstairs, and finally you get this t equal to 2 pi under root gme, and small r is radius of the earth plus height of the this height of this satellite from the surface of the earth. Okay, all right, so I hope let me just quickly decide one pen. Okay, so this height is typically for geostationary. For geostationary, this time period is 24 hours, and you can calculate this height. It turns out to be 35,000 786 kilometer. Once you put the value t here, right? T equal to 24 hours. This site is approximately, we simply remember 36,000 kilometers. If you remember 2011 or 2012, I don't remember exactly the year. In preliminary examination, the question was from the geostationary satellite itself, right? So geostationary satellites have their projection on the equatorial plane and they revolve around the earth in the same manner as earth, rotates. So earth takes 24 hours to complete one rotation, and these satellites also takes same time, and therefore they have to be launched at this height, which is 36,000, around 36,000. Okay. Example of these satellites are INSAT series, GX series, and other notable examples are there, right? Low Earth orbits are approximately at the height of 160 to 2,000 kilometers, and in between 2,000, if you were to go from 2,000 to 36,000 kilometer, you have these medium Earth orbits. So this is the basic idea. If you want to know a bit more about these, Earth orbits. So geostationary Earth orbits, this diagram you can get it from Wikipedia. This is awesome diagram. You can see, number of hours. So this time period 5 hours. In this orbit it is 10 hours, and GLONASS it is 10 hours, right? GPS is here somewhere, at this side, and you have this formula, time period equal to 2 pi under root g mass of the earth. This is radius of earth, height of the satellite is 3 over 2, है ना? इसका कितना हो जाएगा? Power 3 over 2. You can calculate. And if you reach up to 24 hours, you get geostationary satellites, right? So you have this idea. For example, ISS, International Space Station, it is at the height of 400 kilometers. So it will make many revolutions per day. We have made video on it. You can watch it. You can see it, right? Okay. So geostationary Earth orbits, and these satellites are at the height of 36,000 kilometers approximately, which you should remember. And their time period is 24 hours. The high altitude allows a single geo satellite to cover approximately 1/3 of. एक satellite 1/3 of Earth को क्या कर सकती, cover कर सकती. This is the benefit. But the drawback is high propagation latency. There is a latency. Signals जब यहाँ से यहाँ टकरा के जाएंगे तो there will be latency. Latency का मतलब gap होगा उनमें, है ना? तो अगर आपने hello कहा तो हेलो वहां से सुनने में आपको थोड़ा सा गैप नजर आएगा. तो इट इज नॉट सुटेबल फॉर टाइम सेंसिटिव एप्लीकेशन लाइक वीडियो कॉन्फ्रेंसिंग और रियल टाइम ट्रांजैक्शन, फॉर एग्जांपल बैंकिंग ट्रांजैक्शंस, राइट? दे बिहेव लाइक बेंट पाइप्स एंड दे रिले सिग्नल्स बैक टू द अर्थ, राइट? सो वी हैव अनदर वन, मीडियम अर्थ. मीडियम अर्थ ऑर्बिट्स आर बिटवीन 2000 to 36,000. Okay, so if these satellites are at the 2000 to 36,000 किलोमीटर, कॉमन सेंस आप समझ गए होंगे. Number of satellites ज्यादा लगेंगी, लेकिन at the same time latency will be decreased, so their latency is often insufficient for many real-time applications. That is drawback, but latency is lower than the geo satellites. But again, one serious thing about them is you need constellation of satellites for global coverage. It means you need a number of satellites for global coverage. Okay, one example is O3b MEO constellation, right, which consists of 20 satellites. तो अगर 1/3 जियो एक को कर रहा था अर्थ को, तो वी नीड अप्रोक्सीमेटली 3 सैटेलाइट्स टू कवर एंटायर अर्थ. दैट इज द ब्यूटी ऑफ जियो. ओके, जियोस्टेशनरी अर्थ satellites. All right, now we are going to cover quickly, which is our discussion, LEO satellites, which is the part, for example, Starlinks, है ना? तो Starlinks जो है वो किस हाइट पे? इट इज अराउंड 550 किलोमीटर की हाइट्स पे है, which has approximately these days, which have 7,000 of satellites these days, and they are planning to have constellation of 42,000 satellites to cover. One satellite is approximately approximately of the size of the table, so small. So they are very small in numbers. So it goes from 106 to, say this height is, let's say this height is 160 kilometer up to 2,000 kilometer. So आप इस हाइट तक अगर जा रहे हो तो वो सैटेलाइट्स कौन सी है? लो अर्थ ऑर्बिट सैटेलाइट्स हैं, एंड व्हिच इज द डिस्कशन, व्हिच इज द टॉपिक ऑफ डिस्कशन ऑफ टुडे, राइट? Their proximity to Earth results in very low latency. That is the beauty of these satellites. You get connectivity with extremely low latency, right? They are very small, often the table sized, making them cheaper and quicker to deploy. Their main disadvantage is smaller coverage, so you need thousands of constellations of thousands of satellites. That is one drawback of these satellites. Okay, I hope this is clear to you. Now quickly let me talk about these LEO satellites. How do they work? So there are constellations n number, thousands of, n number means thousands here, not mathematically. So if you have this source is यहाँ source से एक electromagnetic wave से आपने कोई signal भेजा. These satellites are internally connected and it is called optical inter-satellite links, which allows satellite to communicate directly with each other, and therefore they create something is called internet in the sky, है ना. तो ये सैटेलाइट इससे कनेक्टेड है. This satellite is connected to this satellite. This satellite is connected to this satellite. But you should look at the situation in a curve, in a curved manner, right? So let me, like this curved manner, okay? Curved manner. Curved manner. Why I am saying curved manner? Because Earth has curvature, right? तो इस curvature में अगर आप देखोगे, तो मैं, all right, let me make this right. तो अगर आपको इस कर्व से इस कर्व तक कोई क्या चाहिए, कोई सिग्नल ट्रांसमिट करना है, तो व्हाट यू आर गोइंग टू डू, you are going to send signal to this satellite. These satellites are now communicating with each other so fast because the speed of this is 3 into 10 raised to power 8 meter per second. This is 3 lakh kilometers per second. एक सेकंड में 3 लाख किलोमीटर दूर जाती है इलेक्ट्रोमैग्नेटिक वेव. That is the beauty of these electromagnetic waves. Alright, so this is how it works, है ना. तो आप क्या करोगे, यहां से वो कम्युनिकेट करेंगे और इंटरनेट ऑफ स्काई सा बन जाएगा. एंड दिस गोज टू द डेस्टिनेशन विद इन फ्रैक्शन ऑफ सेकंड, बिकॉज इट इज नॉट वेरी हाई, 3 लाख किलोमीटर के तो एक सेकंड में स्पीड है. वी हैव टू ओनली गो अप टू लेट्स से 1000 किलोमीटर, है ना. तो 1000 किलोमीटर में जाने में कितना टाइम लगेगा, यू कैन कैलकुलेट द टाइम. टाइम इक्वल टू व्हाट, डिस्टेंस ओवर स्पीड. सो डिस्टेंस इज 1000, स्पीड इज 3000, 8 जीरो लगानी ना मुझे, तो 3 जीरो एंड 10 रेज टू पावर कितनी बच गई, 5 सेकंड, इतना बच गया, 1/3, है ना. तो आप यू कैन कैलकुलेट, 3 और 3 and 5 8, 1/3, 0.33 into 10 raised to power minus 5 second. And if you want to really calculate it, 1 2 3 4 5 3 चाहिए ना मुझे, 1 2 3 3 इतना सेकंड, 1 2 3 4 0.0003 second. This is what is the speed at which these signals will go to the, आपका CSAT का पेपर है, तो you should be a bit good at maths, basic mathematics at least. What are the applications? There are many number of applications. First of all, we are going to talk about communication. Number one application is communication, and particularly to remote areas, है ना. Remote areas again, I have to again, फॉर एग्जाम्पल यू आर इन अ डेजर्ट, है ना. आप किसी डेजर्ट में हो, कोई डिफेंस पर्सनल डेजर्ट एरिया में कम्युनिकेट करना चाहता है, मिलिट्री फॉर एग्जाम्पल, है ना. हिली टेरेन, है ना. तो आप हिली टेरेन, डिजास्टर हिट एरिया, इफ यू वांट टू गेट कनेक्टिविटी टू डिजास्टर हिट एरिया, यू कैन सेव लाइव्स, है ना. डिजास्टर हिट एरिया, है ना. उसके अलावा आप देख सकते हो, इट कैन बी इन द मिडिल ऑफ ओशियंस, है ना. Transportation, for example, so you can communicate. It creates now not only IoT but IoE, Internet of Everything. So Internet of Everything, this is what it is going to create, IoE, है ना. Now it is the concept of IoE, है ना. Transportation में it is going to be helpful in transportation. How it is going to help in transportation? For example, navigation. It is going to help in navigation, right, navigation, है ना. and so many things, navigation, rescue, है ना. बहुत सारी चीजें हो सकती हैं. for example, automation. in automation, these satellites are going to provide real time data and they are going to be used for self driving cars, है ना. तो जिसका एक एग्जांपल क्या हो सकता है, self driving cars. Self driving cars can be one example of these this satellite internet, okay. So it can help in logistics also, robotics, है ना. टाइमली किसी चीज को करना है तो आप robotics कर सकते हो. This is another example. You can find out in apart from automation, I have already talked about disaster, so you can have a rescue, fast rescue operation. It helps in rescue operations and particularly which I am always interested, as I have told you, for example, अभी उत्तरकाशी में क्लाउड बस्ट हुआ था तो लोगों की लाइफ्स को आप क्या कर सकते हो, सेव कर सकते हो, है ना, लाइफ्स। तो लोगों की लाइफ्स को आप क्या कर सकते हो, रेस्क्यू ऑपरेशन में क्या कर सकते हो, सेव कर सकते हो, है ना। उसके अलावा डिजास्टर में आपको क्या चाहिए, फास्ट कम्युनिकेशन चाहिए, है ना, फास्ट कम्युनिकेशन चाहिए, एक्यूरेट कम्युनिकेशन चाहिए। तो दिस इज व्हाट यू कैन डू इन डिजास्टर प्रिपेयर्डनेस और डिजास्टर मैनेजमेंट और हाउ टू अवॉइड डिजास्टर्स बेसिकली। ओके, और डिजास्टर बहुत इंपॉर्टेंट है, मतलब इसमें अर्ली वार्निंग सिस्टम जो है, अर्ली वार्निंग सिस्टम में लेटेंसी का बहुत बड़ा नुकसान है ना। तो अर्ली वार्निंग सिस्टम, अर्ली वार्निंग सिस्टम मतलब टाइमली आप क्या कर सकते हो, वार्निंग क्या कर सकते हो, दे सकते हो, है ना, रेस्क्यू ऑपरेशन में कोऑर्डिनेट करने में हेल्प कर सकता है, राइट। हेल्थ केयर सेक्टर फॉर एग्जांपल टेलीमेडिसिन, है ना, रिमोटली कोई पेशेंट अगर बैठा हुआ है तो उसको आप क्या कर सकते हो, मॉनिटर कर सकते हो। तो इट इज गोइंग टू बी अ गेम चेंजर इन हेल्थ केयर, राइट। हेल्थ केयर में फॉर एग्जांपल वी हैव दिस concept of telemedicine, we have concept of this remotely monitoring, है ना, और you can say remote monitoring of patients, है ना, monitoring of patients, you can remotely monitor patients, right. You have another example in agriculture, है ना, एग्रीकल्चर में आप क्रॉप को क्या कर सकते हो, बचा सकते हो, राइट। तो सो इन एग्रीकल्चर व्हाट यू कैन डू, वी कैन लेवरेज दिस इन प्रिसिजन फार्मिंग, क्रॉप हेल्थ एनालिसिस, है ना, क्रॉप हेल्थ एनालिसिस, है ना, क्रॉप को बचाया जा सकता है, क्रॉप प्रोटेक्शन। ओके, उसके अलावा प्रिसिजन फार्मिंग, द कॉन्सेप्ट ऑफ प्रिसिजन फार्मिंग, दिस कैन बी अचीव्ड, प्रिसिजन फार्मिंग। तो जो ये टॉपिक होते हैं, आप केवल आपके एक डायरेक्ट क्वेश्चंस की बात नहीं है, यू कैन राइट योर आंसर इन GS3 एग्रीकल्चर से कोई क्वेश्चन आ गया तो यू कैन कोट एग्जांपल्स फ्रॉम हियर, ओके। सो दिस इज द यूज इन फॉर एग्जांपल एग्रीकल्चर, ओके। बाकी आप खुद कर रहे हैं ना, एनवायरमेंटल मॉनिटरिंग, एनवायरमेंटल इज अ ग्लोबल इश्यू नाउ, एनवायरमेंटल मॉनिटरिंग, है ना। आजकल प्लास्टिक पॉल्यूशन के बारे में बात होती है, वी कैन टॉक अबाउट दिस, यू कैन हेल्प, यू कैन यूज इट इन टूरिज्म, okay, you can use it for defense, energy exploration, mineral exploration, है ना, defense, okay, defense is done, है ना, mineral and energy exploration, right. So if you want to explore other sources of energy, you can use it here, you can use it for many different applications, at least you should write these, this is homework for you, write few your own, find out some other applications of these satellites 13 for 12 13 14 15, है ना। Okay, quickly before winding up this video, we are going to talk about challenges and at least we are going to talk about some basic head, so high cost and infrastructure, even high cost mean affordability, customer के लिए भी, है ना। तो affordability is one issue, affordability, है ना। तो बहुत सारे जो areas हैं, if they are not रिच इनफ, फॉर एग्जांपल अफ्रीकन कंट्रीज में इंटरनेट नहीं आप दे सकते हो सैटेलाइट से, लेकिन अफोर्डेबिलिटी, क्या अफोर्डेबिलिटी है, दैट इज मेन क्वेश्चन एक्चुअली, है ना। तो उसके अलावा इट इज लॉन्चिंग एंड मेंटेनेंस कॉस्ट इज वेरी एक्सपेंसिव, है ना, तो दैट इज आल्सो वेरी सीरियस प्रॉब्लम। it has still low latency, but latency is not a big issue. Reliability issue is there, reliability, so reliability issue is there, reliability issue. So reliability means simple, whether we can rely on these things, है ना। तो weather conditions में for example rain, storm, it can affect what for example weather can affect, है ना, we don't know about it yet, है ना, पर जब तक स्काई क्लियर नहीं है तब तक ये सिग्नल्स क्या होंगे, सही नहीं आएंगे, है ना। अगेन स्पेस डेब्री एंड ऑर्बिटल कंजेशन इज देयर, राइट। So space debris is a serious problem, we should know about it because this is part of your UPSC understanding, UPSC syllabus understanding basically, है ना। So thousands of satellites increase the risk of collision, creating more space junk, they raise long term sustainability and safety concern in space, right. Other regulatory challenges are there, for example who are going to regulate, regulatory challenges. So in space, regulatory challenges are a serious thing. It requires international coordination for frequency band also, है ना, risk of interference with existing telecom or broadcast service, cyber security and data, तो cyber security is part of your syllabus and that is again part of this system. And जो आपका privacy है, basically data privacy, that is one issue with these satellites, right? Signal transmitted over open space and more, they are vulnerable to interception, jamming, hacking, etc. Environmental geopolitics है ना, तो environmental impact. So you read about this environmental impact, you read about geopolitics, I am giving you basic, head geopolitics. Okay, so इसमें क्या geopolitics होगी? Satellites operated by foreign companies raise sovereignty and national security issues, right? They have shorter lifespan, that is one thing, right? So shorter lifespan, typically 5 years to 20 years, but it can be less than 5 to 7 years, on average, right? Another one is limited bandwidth per user and limited bandwidth, okay, limited bandwidth. And finally, point number 10 is integration with existing network, right? Integration with existing network, these are some of the challenges of satellite internets. Okay, so you must be following the news. And let me tell you one thing very quickly, कोई भी topic किसी एक class से complete नहीं होगा. You have to read it again and again, over and over, as it comes in the newspaper. And अपना knowledge आपको इस तरह से क्या करना है, बढ़ाना है. फिलहाल you write a question and let me give you the question. Satellite based internet services have the potential to bridge India's digital divide, but they also pose regulatory, security and economic challenges. Discuss the prospect and challenges of satellite internet in India. Okay, 250 वर्ड्स में दो बार आ गया है प्रिंट करके, तो आपको 250 वर्ड्स में इसको क्या करना है, लिखना है. So we wind up this video. Thank you so very much. If you like video, don't forget to like, share and comment. Don't forget to subscribe. Thank you so very much. See you guys until next time. Thank you.